Hello, this video is going to show how we can achieve functional safety using the Microsemi SoftConsole IDE and a SmartFusion2 device. Now connected to my laptop at the moment, I have this particular SmartFusion2 Maker board. Now this is the SoftConsole IDE, and inside the IDE I've created a number of projects, and it's this one that I'm particularly interested in at the moment. So let's check we can first of all build. So let's do a build project. And there we can see we've successfully used the GNU compiler and we've generated an executable. Now what I'd like to be able to do is first of all, I'd like to be able to examine this code and see, well, is it compliant to a coding standard such as the MISRA 2012? I'd like to be able to look at the code and measure some metrics on the code, such as the cyclomatic complexity. I'd also like to be able to execute this code, and as it executes, I want to find out, well, which parts of this code have we exercised and which parts have we not exercised. And then I imagine we won't have a full coverage for this, so I'd then like to use the unit testing tool in order to be able to complement that coverage. Now, we've done a build, so let's do another build, but this time let's do it from within the LDRA build system import. So that's the same directory where my source code is. I'm now going to call my build, and as it does so, we're going to be able to see here it's called the GNU compiler. We've then passed the results, and we can see we've generated an executable, as well as we can see we have a number of source files. We've also found the necessary include paths and also any necessary preprocessor symbols. So we now have everything we need in order to be able to statically analyze the code using TB Vision. Well, to save time, I've already done that. And so here we can now take a look at the results. So let's just right click on here and let's do a code review. And as can be seen, we have a number of violations here. So code wasn't written to be compliant to MISRA, and a lot of these could be very simple to fix. For instance, here, username starts with underscore. Well, if I double click, it opens up my editor and takes me to the place where we can see we have a define, and indeed it starts with an underscore. Well, that is going to be very easy to fix. Okay, at the same time, I'd like to look at the quality of the code. So let's start by looking at a system call graph. And the system call graph shows us all the functions. We can see how they're interconnected, and they're also color coded to show us system calls, normal calls, etc. Now let's take a look at this and put it into maybe a view that shows us maintainability, and that's where we've measured a number of metrics giving us an idea of, well, is the code maintainable? And one of the most interesting metrics is the cyclomatic complexity, and I can sort and find the most complex function. Well, let's view that graphically with a flow graph. And so here we have a graphical representation of the code. And if I click on a particular block over here, we can see the corresponding block over there. Again, if I was to click on a block inside the code here, we can see the corresponding block. I can also click on the various branches, and I can see this is a branch from this point down to here. So what I now want to be able to do is to execute this code, and as it executes, I want to find out which paths have we taken through this code. So we're going to instrument the code by putting probes around the start and end of each block. So let's go and perform the dynamic analysis. So in this particular case, it's going to generate the instrument code, it's going to build it, it's now using the JTAG to talk to the target. We've executed it, we've got the results from the target, and let's take a look at a system call graph again. And this time, let's put it into a coverage mode, and we can see we've got pretty reasonable coverage. We haven't got full coverage for integer to ASCII. Well, let's view it graphically, and now we're going to be able to see color-coded in green the paths we've taken through the code, and in red the parts of the code we haven't executed. So a number of blocks we haven't executed, as well as a number of branches here that have not been executed. So if I want to get full coverage of this, then we could use the unit testing tool tbrun in order to be able to get into these other parts of the code. So let's start tbrun. And inside TV Run, what I'm going to do is I'm going to open a sequence of test cases that I've previously created. So let's go into here and we'll open this sequence of test cases. There we can see we have 7 test cases, and for each one we can see the inputs as well as the expected outputs. So let's go and execute this. So once again, it's generated a harness, it's built it, it's downloaded to the target. So in this case, we can see we're using JTAG to execute it on the target. We're getting the results back, and we're going to be able to find, hopefully, that all our tests have passed. And at the same time, we should be able to look at the coverage, and we should be able to see that now for this function integer to ASCII, we now have 100% statement coverage, 100% branch decision coverage, and 100% MCDC. Okay, so hopefully that's given you a quick overview of how we can work with the Microsemi SoftConsole IDE. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.